Hello everyone. Today's session will discuss three main problems of Module 1. We will start with the binning techniques problems, then we'll discuss min-max problems and z-score normalization. Let's first go through the binning techniques problem. So consider the question is like this. You have a set S with these other values 12, 14, 19. So you have these values in the set S. Upon this set you have to apply various binning techniques and we have to show the result. So the binning concept we have discussed in the previous session. I will give a link to that in the description box. So let's see how we can solve the problem. So the step one is what you have to do is you first have to make bins. Okay, equals bins in the sense you have to say make equal signs bins. Since in the problem the bin size is not given, we can only assume the bin size. Let's take it as 3 so that I can equally distribute it, because I have here 9 values in the set S. So I'm going to make the bin size as 3 so that I will have 3 bins each of size 3. Okay, so by equal frequency bin method, data should be distributed across the bins. So assume the bin size as 3, then the above data will be distributed across the bins as shown. Bin 1 would have the first 3 values 12, 14, 19. Bin 2 will have the next 3 values 22, 24, 26. Bin 3 would have the last 3 values 28, 31 and 34. Now we have to start with the binning methods. We have discussed the various binning methods in the earlier sessions. In this problem we are going to apply two binning methods. One is smoothing bins method using the mean method, and the other one is the boundary method. So let's first see the method 1 by smoothing bins method using beans. So basically means in the sense we are going to calculate the average. That's it, right? So for each bin calculate the average and replace each value in the bin with its average. That's all. So if for example in bin 1 the values are 12, 14, 19. So let's take the average of this, that is 12 plus 14 plus 19 divided by 3 because we have 3 values here. So the mean value or the average value of bin 1 is 15. Similarly, find the mean of bin 2. 22 plus 24 plus 26 divided by 3. I get the mean value as 24. Bin 3. I get the mean value as 28 plus 31 plus 34 divided by 3. I get the average value as 30.3. So now I am going to replace each value in the bin with its respective mean value. So bin 1 the mean value is 15, so replace all the 3 values with 15. In bin 2 the replace mean value is 24, so replace all the 3 values with 24. In bin 3 the mean we got as 30.3, replace all of them with 30.3. So this is the method 1. Now using the second method by using smoothing by bin boundaries method. So boundaries in the sense I am going to calculate the minimum and the maximum value in each bin. Okay, so in bin 1 the minimum value is 12 and the maximum value is 19, right? And in bin 2 the minimum value is 22, the maximum is 26. In bin 3 the minimum is 28, the maximum is 34. Now what I am going to do is for each value in the bin, whichever is near, right? If it's near to the minimum value, put the minimum value there. If it's nearer to the maximum value, put the maximum value there. So for the bin 1, 12 is a minimum value, and anyway that is only the minimum value, so 12. The second value is 14. 14 is nearer to 12 as compared to 19, and therefore replace 14 by 12. And the second 19 is a maximum value, so write 19 there. In bin 2 the minimum value is 22, so first value is 22. The second value is 24. Since 24 is equally is at a distance of 2 from minimum value as well as a distance of 2 from maximum value, so you can choose either. So in this case I have chosen the minimum value, so minimum value is 22. So that is why I have replaced the value 24 by 22, because I have replaced it with the minimum boundary or the minimum value 22, whichever is near. If it's equally near to minimum and maximum, you can select either. The last one is 26. Now see the third one. The minimum value is 28, write 28 here. Now 31 is again equally distance from the minimum value as well as the maximum value. In this case we have put it nearer to the maximum value. So the values here you get are 22, 28, 34, 34. Okay, so basically what is this method, bin boundaries method, is we first find the min and maximum value of the bins, which is nothing but the bin boundary, then transform the rest of the values to whichever is nearest. Okay, so that is about the binning method. Now coming to the next problem, we will discuss the min-max problem. Now this question is, they have given us a set V as 88, 90, 92, 94. We have to apply the min and max procedure and map the marks to a new range of 0 to 1. So we have discussed this concept in the video before, for which again I'll give you the link. So the solution is like this. Step 1, you first find out which is the minimum and maximum value in the list V. So in the list V, the minimum value is 88, maximum is 94. So take min is equal to 88, max equal to 94. Step 2, find new max and new min. Because here we are going to do normalization, I'm going to change the value of all of these. They should be in the question. We have to do normalization in the sense all the values here would be changed to a range between 0 to 1 only. Okay, so therefore the new, because in the question they have given new range is 0 to 1, therefore new min is 0, new max is 1. Now step 3, perform the mapping. So this equation we have discussed in the previous video. So what is this equation? Min dash max is equal to V minus min divided by max minus min into new max minus new min. So basically V is nothing but the value for which I'm going to calculate the new mapping value. That I have to subtract with the minimum value divided by max minus min into new max minus new min. So for each value I have to repeat this procedure. So for the value 88, what is the new value? Basically at the end of this you should have the values calculated between the range of 0 to 1. Okay, so for value 88, min max, new value would be new min max is equal to V is what? 88, this value, minus what is minimum value? 88, divided by max minus min. Max is 94, substitute, minus 88, into new max is 1, new min is 0. So you get the value as 0. For next, repeat the same thing. For value 90, it repeats the same thing. Everything else remains the same, just the V value keeps changing, right? Because min would be 88, max would be 94, new max is 1, new min is 0. The only thing that changes is V value. Here it is 88, here it is 90, next for the next 92, and this is 94. So if you observe that the values calculated, they're all within the range of 0 to 1. So it can be observed that the marks 88, 90, 92, 94 are now mapped to a new range of 0, 0.33, 0.66, 1. So thus the min-max normalization range is now between 0 and 1. So we have obtained the normalization. Now going to the next problem, that is the z-score normalization. This is an other way. We have discussed this, right? Normalization, two methods, min-max and z-score. What I discussed before was min-max. So this is an other way of doing normalization. So z-score normalization, the question is like this. They have given us a list V is equal to 10, 20, 30. I have to convert these marks to z-score. So here the step 1 is you first find the mean value and the standard deviation. Okay, for the set V. So this is a V. What is the mean value? Mean is nothing but represented by the symbol mu. So 10 plus 20 plus 30 divided by 3, which is 20. So I'm getting the mean value mu is equal to 20. Now find the standard deviation. Standard deviation formula is sigma is equal to square root of sigma, or the product of x minus x bar the whole square divided by n minus 1. What is x bar? X bar is nothing but mu. That is the mean. So for each value of x, I have to calculate x, subtract it with what the mean, and then add it. So x would be changing. So the first time it is 10, second time x is 20, it's coming from the list V. Third time the x value is 30. Now subtract with mu. Mu is already calculated. Mu or x bar, both are same. Okay, so first time square root of the numerator would be 10 minus the mean 20 the whole square plus 20 minus 20 the whole square plus 30 minus 20 the whole square divided by n value is what? How many values we have in V? 3. So 3 minus 1, if you calculate, you're getting the standard deviation as 10. So standard deviation represented as sigma is equal to 10. Now step 3, you have to find the z-score of the marks. So how do you find the z-score? This formula we have discussed in the previous video. It is V star is equal to V minus mu by sigma. Now again we have to find the z-score for each value in the set V. So z-score of 10 you have to find. So 10 is nothing but V. So 10 minus mu is nothing but mean. I got as 20 divided by sigma. Sigma is nothing but standard deviation 10. So the value is minus 1. Similarly find z-score of 20. Just replace V with 20. The rest mu and sigma will remain the same. Next again, z score of 30, replace v with 30. 30 minus 20 divided by 10. So what is the new normalized value we are getting is z score of marks 10, 20, 30 is minus 1, 0, 1. So basically here you can see that the range of these values are in the range of minus 1 to 1. Okay, so that was the three problems that we have discussed. In the next session we will have another session of the rest of the problems of module 1. Thank you so much.